The phrase quantum computer always makes people pause. For some, it's pure wonder. For others, pure fear. Because it doesn't sound like just another machine. It sounds like science fiction. It sounds like something that shouldn't even exist, and yet it does. Right now, the devices you're using, your laptop, your phone, even the servers running the entire internet, they all rely on bits. A bit is simple, 0 or 1, black or white, yes or no. From billions of these tiny switches, we get videos, music, maps, even your messages scrolling through the screen. It feels limitless, but in truth, it's still bound by the rules of classical physics. Quantum breaks those rules. A qubit doesn't play by 0 or 1. It can be 0, it can be 1, and thanks to superposition, it can be both at the same time. Think of a coin spinning in the air, not heads, not tails, but suspended in possibility. That's the raw power a single qubit holds. But here's where it gets truly mind-bending. Entanglement. 2 qubits connected so deeply that the state of one instantly affects the other, even if they're separated by miles. Einstein himself called it spooky action at a distance. And yet, it's real. It's been tested, proven, verified. Add to this interference, the ability to make some quantum paths cancel out while others reinforce each other. It's like conducting a symphony of probabilities. And when you put superposition, entanglement, and interference together, you get a computer that doesn't just try one path after another. It explores countless paths all at once. That's why people whisper about its power. That's why the word quantum feels dangerous. Because with enough qubits, a quantum computer could do what classical computers would need millions of years to even attempt. So the big, scary question, could it hack everything? Could it break every password, every bank account, every social media login in seconds? Could it shred the very locks that keep the digital world secure? The shocking answer is yes, at least in theory. Today's cryptography, the encryption guarding your private messages, your financial transactions, even the military secrets, relies on problems that classical computers can't solve in reasonable time. But a powerful enough quantum computer could cut through those defenses like a hot knife through butter. RSA? Broken. Elliptic curves? Shattered. The codes that feel unbreakable today would crumble instantly. But take a breath. We're not there yet. The quantum computers we have now are noisy, unstable, fragile. They can run only a handful of qubits before errors overwhelm them. Right now, we have maybe a few hundred. To crack modern cryptography, we'd need millions, even billions of stable, error-corrected qubits, and that's decades away. Still, scientists aren't waiting. Governments and tech giants are racing to develop post-quantum cryptography, new locks designed to survive the quantum storm before it arrives. Because the truth is, once the genie is out of the bottle, there's no putting it back in. But here's the twist. Quantum computers aren't just about hacking. They're about creating. They could simulate molecules down to their quantum properties. They could help us design miracle drugs that cure diseases once thought untouchable. They could unlock clean energy by building better batteries. They could discover materials that don't even exist yet. They could optimize traffic in entire cities, transform global supply chains, reinvent financial models. Problems too complex for today's machines could collapse under the weight of quantum speed. And yet, don't expect to carry one in your pocket. Quantum computers won't replace your phone. They won't replace your laptop. They're a new class of machine designed for a new class of problems. They will live alongside classical computers, not replace them. So should you be afraid? Maybe a little, because the stakes are real. The power is unimaginable. But fear is only half the story. The other half is wonder. Wonder that we, fragile humans, can bend the strangest laws of physics into working machines. Wonder that the universe, at its deepest level, can be harnessed, shaped, and used to solve problems we once thought impossible. Quantum computers may not steal your password tonight, but they might save your life tomorrow. And that is even more exciting.